Now let's consider the following joint probability distribution for the random variables x and y. So x has the values 2 and 4, y has the values 5, 6, and 8, and then we have the given probabilities. We can find the probability that x is 2 in the same way that we have been doing by adding the values in this row. We would wind up with 0.25. Then find the probability that x is 4 by adding the entries in this row, and we would wind up with 0.75. Find the probability that y is 5 by adding the entries in this column. We would get 0.32. The probability that y is 6 will be 0.12. And the probability that y is 8 will be 0.56. And adding these two entries gives us 1.0, and adding these three entries gives us 1.0. So this is a valid probability distribution. Now what we will do in order to establish independence is check the conditional probabilities against the probability for the individual value and see if they're equal. So in other words, I'm going to find the probability that x is 2 given y is equal to 5. And what I should find is that that is just the same as the probability that x is equal to 2. So this probability would be found by dividing 0.08 by 0.32. We're given that y is 5, so we only care about this column, and the entry in that column where x is 2 is 0.08. So 0.08 divided by 0.32. And this gives us a value of 0.25, which is in fact the probability that x is equal to 2, this entry. So we have not violated the condition of independence yet, so we'll continue on. And we'll do this for every entry in this table. We would do the same thing for the probability that x is 4 given y is 5, and then the probability that x is 4 given y is 6, and then the probability that x is 4 given y is 8. So we have established that the random variables x and y are independent. And if we were to go about the process of finding the expected value of x, we would find that it is 3.5. The expected value of y is 6.8. And the expected value of x plus y is 10.3. And again, what should happen is that this expected value will be the same as the sum of these two.